7.3. I'm not really sure what I wanted to do today. I tried to make a short video about building an aircraft, but of course I'm long-winded and always try to do my Dhamma talk and enlighten some things about life while I build my Kerbal programs. So I'm just not sure what I want to do today. Anyway, as you can see, I have my program modded, but I don't have it modded in any way that would affect a variation on a stock game. I do know the last aircraft I built was probably modded with both cockpit and gas tank, which were streamlined and smaller, so of course in Kerbal you won't even have that option. I mean the stock game. Now, the problem I have in career mode, let me go ahead and pull our game up, see what I've got. Actually, the last video I built with the non-stock aircraft was probably not in this game, but in my private personal game. So let me just see where we are. You know, these guys make all these fancy videos, but it doesn't do you much good in career mode when you've only got this much of the tree unlocked. So you basically have limits to what parts you can use, and of course how evolved they are and to what power they produce. Of course in the early game it's always going to be low evolution and low power. So let's just try something crazy and come in here. I built a fancy aircraft. Let's just see if we can build a basic simple. Okay, I'm just going to stick that on his head for right now. I'll show you why in a minute. Alright, liquid gas. And I'm going to take this. 2 of them. Like that. Alright, I may produce, put some parts between these, but that's the basic start. And that's your basic fuel tank configuration. Now, of course, our choices for engine are limited. So you can either put 1 in the middle or 2 on the back. We'll go 2 on the back. Alright, now go straight to plane parts. And remember, if you hit D, it will flip that one around. And of course I'm going to throw a let's not forget our air intakes. We need 2 of those. Alright, is it looking better, guys? Let's throw this back about as far as we can get it, and then I can use this tool here, the positioning tool, slide that back and match that. Oh, problem. I didn't have 2 wings on. Right, so the reason we have wings on left and right, that's called balance, and we need balance for a lot of stuff. I'm actually going to pull this wing off, and we'll put it right here. Now push the E button, and I don't know if you saw that wing drop down like that. That was a single strike of the E button when before I placed the part. Alright, so look at me, look at me. Alrighty, now the thing we're going to need to know from this point forward is the center of mass and this is going to help us produce our balance. So I'm going to move this part to the center of mass. I'm also going to lower it down so I can get in the door. I could put a wing between them. Yeah, let's try that. No promises yet. Alright, wing B's too big. Let's try this wing right here. Turn the... Okay. Now if I do just one, this could mess us up. So I don't know if I'm going to do this. I may not do it. I'm just checking on something. See what I'm doing? Ah! Oh, let me take the lock off. Yeah, see, I can't quite get the spread. So this wing, you can see a little bit of it. I might just leave it there. See how it feels. I mean, if it flies. But what I'm not going to do is put any flaps on it. So these would be flaps. The game calls them elevons. I've heard them called all kinds of things. Basically, they're your the wing would be called your lifting surface, and this would be your control surface. So, if you just want a nickname for them, flaps is the best. Alright, so I'm going to lock that up, get to. So you saw me flipping around with the WSD QE keys, and once we create that, there's no need to do all that again. You just hit alternate and click on it, and it should give you a part flipped. So we have to assign pitch, yaw, and roll. That's what we work with, is pitch, yaw, and roll. That was in the other video. I won't go into explaining it. So we're going to do, this is the roll wing. This is the pitch wing. This is the yaw wing. And then I'm going to make this a pitch assist. So we have roll, pitch, pitch, and yaw. In Europe they call this the rudder, and some American pilots call it the rudder too. So yaw control or rudder. Alright, looks pretty good. And what I've done is, you have to understand planes fly different empty, so we have to pull that forward, and then we're going to have to adjust for that. Okay? So what I just did is I put that in the middle of my wing when I'm empty. I don't think that leaves room for him to get in and out, but let's just not worry about that right now. We have to worry about it if this flies. Now if I put gas back in this, let's do that. Because remember, we have to land empty, so it has to fly better empty. But if it takes off a little clunky, so be it. But then you burn your fuel off, and of course you're probably landing empty. And if pilots have an emergency, especially the big jumbo jet pilots, we call them heavies, they will dump their fuel before they return. I'm going to turn that off right now because we've found the center of lift. And I'm going to put a front wheel on it, but I don't like the steering, so I'm going to turn that off. We'll steer with our yaw. Now we have to know where to put the rear gear. So that's this, and that would be called your center of lift. So we had our center of mass before, but then we put wings on it and control surfaces, creating, drag and resistance and lift. And there's a center for that too. At what point of the aircraft does it lift from the center from? So it's like balance, but it's lift. So imagine the first guys that had to figure this out. That's probably why Orville and Wilbur Wright didn't even have wheels on their aircraft. So let's just position that again. I got a little lost in the other orientation. So that's right on the center of it. Now I want to check my mass while I'm here. So we can fly. That's in the center of the wing, even though it's going to want to pull up hard and fast, maybe. We'll see. And we have the wheels on the center. So now I'm going to adjust everything to the ground. And there's another way to do this, but I'm just going to do this the easy way, and that's set that wheel on the ground and watch it just before it goes in, and then we have to put these in the same spot. Now, I am so low to the ground, I am concerned about what we call tail drag. So, all pilots should be. But rather than flip out over it, I think what we might do, I might raise this wing up. Let me try something. Experimental, please. So now that I've got the wheels adjusted, I'm going to take the whole craft and lift it back up in the air so it's easier to work with. There we go. Alright, so I'm going to do this single wing. I'm going to lift it up like that. And come over like that. Maybe it might look too hokey, but we'll try that. And the reason I came up with that is because of this, and that's called the center of thrust. So what we're basically looking for is a thrust moving in a backward direction and the center of lift behind the center of mass. Now we have a controllable forward flying aircraft. If I were to try to position the wings and set all this up so the center of lift is directly on top or in front of the center of mass, it will become slippery or very difficult to fly in the second sense where I'm in front. If it's right on top, you have what we call a VTOL. That's a vertical takeoff and landing craft. This is a wonderful place to be when you're a VTOL, but we are not. We are a fixed wing aircraft. Means it's bolted down. A lot of times people describe the fixed wing aircraft, especially in the military, as the wing that's overhead. And that may be super correct. But I know my wings are bolted down. Anyway, if I'm using the term wrong, I apologize. But I know for a fact they are like a Cessna 172 is referred to as a fixed wing aircraft. Anyway, I may not be, but what we're going to do now is just save this aircraft. Call that AC1. Save it. Nope, I'm not going to overwrite the other one. I want to go see what it is before I throw it away. And I'll call this AC12 and save it. And we're going to go see if it flies. So that was how to build a basic aircraft that flies. Now, you see my bouncy? Alright, so what's going on there is it's too much weight for this gear. So we should probably unburden it. Or, this is gas, but if this thing flies like this, I'll be very pleased. And the reason that is because this will have some distance on it. It's not heavy at all. It's basically a wing and a gas tank with a cockpit. I mean, yeah, that's exactly what it is. Well, it's got takeoff gear, some control surfaces, so... Anyway, how this works is we partial power as we go down the runway. Of course, we've received all the permissions from ground station, which is right here. And we're going to build up speed slowly. And then as we get closer to ground station, we're going to increase our speed. And then I think about 50 I can rotate or pull back. Yep, I was right, 54. I did it. So I started to lose speed, so I'm going to just do a nice glide slope of about 5 meters per second. If you can see on the top of the screen, I have a vertical speed indicator that's on 10 right now. So I'm going to give it gas because I'm only doing 64. I feel safe and in control. Alright, now I have let go of the stick, and I'm kind of monitoring the aircraft for its behaviors. This would be what you'd do if you're a test pilot, because the aircraft has to be able to fly itself to a certain extent. Not under full throttle, actually under no throttle at all. So so a test pilot, he might, of course altitude is a pilot's friend, so he's not going to do anything crazy until he gets up. Like, he wouldn't do anything now, he's just testing straight true flight, climbing in altitude and speed, probably very happy that he's pitching 30 degrees and still increasing in speed. That's life of the jet fighter. If you have a propeller plane, you won't be able to do this. You'll be looking up and see that you've pitched 20 in your surface speed, which we measure in meters per second, but real aircraft measures in nautical miles per hour. We measure meters per second. It's an easy enough conversion. You can do it just into about anything. Miles per hour, kilometers per hour, nautical miles, everything. But generally speaking, aircraft is Navy. Anytime you're like boat on the water, craft in the air. I'm going to kill my gas. So we're doing another test now. We're at 3,000 feet. Now we're driving to the ground. And we're still maintaining our speed at a 10-degree pitch. So, of course, if you were ever wanted to be a pilot or a test pilot, then you could. Alright, I'm giving it gas. I'm thinking of going back to Kerbal. You can make videos like this, or I recommend that while you fly you practice talking, because when you're a test pilot you're hooked to the radio and they want feedback, so you're constantly telling them what's going on. I mean, constantly. So now I have Kerbal runway in sight. I'm putting it on 270, adjusting my azimuth to 0 degrees. I've got my throttle on 33%. Stuff like that. We've got a 5-degree glide slope at 2,100 meters. On Kerbal approach at 269er. And when you say 9, you gotta say 9er. Anyway, this could be a catastrophic landing. And the reason I say that, tower control, this is Jebediah 1. Request permission to land on 270. Anyway. Permission to denied, Jebediah 1. Correction tower, mayday, mayday, we have an emergency. We're full of gas and we've lost all engine power. See, I just shut the throttle off, so, you know. In an open-ended game like this, sometimes you have to do mayday emergencies or practice real-world technique while you're doing this. This is not good, so let's just talk about why it's not good. I was at stall speed. Let's just call stall speed 55. So that means we start falling out of the sky and stop flying. When we stall, the only thing we can do is point our craft towards the ground. Now, if our stall speed is 55, wouldn't it be nice to land our airplane at 56? Right? So we're kind of stall into the ground. That's a super exaggeration. Of course, you want to give yourself more tolerance. But essentially, that's what I'm talking about. So what pilots do on a normal approach, of course, we're on a Mayday approach. See, I'm going to go down below 55. Oh, I've found my gas back. Now we can talk about what pilots do on a normal approach. What they're going to try to do is, and I'm low on altitude, so I'm really playing with fire here. You can see my direction, which is the bottom arrow, not the way my nose is pointed, but where my airplane is flying. I just brought that back to 0, so good. And I'm at 50. That's perfect. So what we've done is we've established on the throttle control where my sweet spot is. 50 at a 5-degree glide slope. So basically what I'm doing is flying. It's a little rocky, a little rickety. Of course, if we were in a row-craft, we'd have our flaps down. So I've got a really nice glide slope that I'm happy with. I mean direction, and then the slope comes down like this. I'm going to kill the throttle all the way now, because what I'm having is 80. So I'm going to come on into approach, and I'm going to pull back on the stick and burn that speed off. So pulling back on the stick, and I'm burning the speed off. Okay, I'm coming too hard. Definitely a Mayday landing. I popped an engine. But anyway, so the reason that happened is because we're full of gas and we're still too heavy. Look at us rocking down the runway. Alright, so I had to roll off the side. That would be customary. Put on the brakes, of course. Now you can see the Kerbal physics engine. Let's just lock the brakes up right there. Look, the physics. We came in so hard and fast and so heavy, it's caught in the physics translation. So what it has is built up energy into all the parts, and it's releasing it now. And it's kind of funny. So this is the interesting thing, the flaw of the physics model. So they try to be as true to physics as they can, but sometimes you'll have a part and it's contact with the ground, and it must get into some type of look like it's spinning now, like a top spinning. If we watch it long enough, it will stop, unless I've got spring-loaded gear. And in the Kerbal world, it's possible to create what we call a momentum engine. So I could be in a momentum engine state. So anyway, I'm going to try a right and left. Rock, right, left. Okay. I just getting on the throttle now, and I'm calming it down. Oh, it's picking up. Anyway, I'm going to end the video here. But it was good about how to build your basic flying craft in early career mode. So thanks for watching.